Good evening, everyone. Myself N.Akshith Kumar. Now I am going to present the nuclear power plant. So under the guidance of Jignesh sir. So this is the overview of our project. Introduction, first nuclear power point, components of nuclear power point, types of nuclear reactor, working of nuclear reactor, environment impacts, safety and regulations, and conclusion. Now, this is the introduction part. As our global population grows and economy expands, the demand for electricity is at an all-time high. Traditional sources of energy such as coal, oil, and natural gas have a long backbone of our generation infrastructure. However, the reliance on finite resources and eternal environment impacts associated with the destruction and combustion have spread a global shift towards cleaner and more sustainable alternatives. This is the first nuclear power plant. Electricity was generated for the first time ever by a nuclear reactor on December 20, 1951, experimental station near Arco, Idaho in the United States. On June 27, 1954, the world's first nuclear power plant to generate electricity for a power grid started operations at Obinsk, USSR. The world's first scale power station, Calder Hall in England, opened in October 17th, 1956. Now, these are the components of reactor. The first component is control rods, steam generator, steam turbine, coolant pump, feed pump, condenser, and cooling tower. Now, here the diagram represents the components of the reactor. The first component is known as control rods. Control rods are made of material that absorbs neutrons, are inserted into the bundle using a mechanism that can raise or lower the control rods. The control rods essentially contain neutron absorbs like boron, cadmium, or indium. Now, steam generator. Steam generator are heat exchangers used to convert water into steam from heat produced in a nuclear reactor core. Either ordinary water or heavy water is used as a coolant. Now, steam turbine. A steam turbine is a mechanical device that extracts thermal energy from pressurized steam and converts it into usual mechanical. Various high performance alloys and super alloys have been used for steam generated turbine. Coolant pump. The coolant pump pressurizes the coolant to pressure of the order of 155 bar. The pressure of the coolant loop is maintained almost constant with the help of pump and pressurized unit. Now, feed pump. Steam coming out of the turbine flows through the condense for condensation and recalculated for the next cycle of operation. The feed pump circulates the condensed water in the working fluid loop. Condenser. Condenser is a device or unit which is used to condense vapor liquid. The objective of the condenser are to reduce turbine exhaust pressure, to increase the efficiency, and to recover high quality feed water in the form of condensation and food back into the steam generator without any further treatment. Now, this is the last component, mainly known as cooling tower. Cooling tower are heat removal devices used to transfer process waste heat at the atmosphere. Now, this is a diagram representing the coolant tower. Now we are going to discuss about nuclear reactor. As you can see that the diagram representing the nuclear reactor. So at first we can see this is a control rod, this is a pressure vessel, this is a water pump. Now this component is water, this is condenser, this is cool condenser water that will intake lake or that is connected to a lake or river. This is the water spray, this is warm moist air, and this is non-radioactive water pressure. These are the transmission lines. This is electric generator. This is turbine and containment structure. This is known as containment structure, and it is known as steam. Now, these are the parts of the nuclear reactor, and the following diagram represents the nuclear reactor, the rough diagram of nuclear reactor. Now, these are the types of nuclear reactor. The first one is pressurized water reactor. The second one is boiling water reactor. The third one is pressurized heavy water. Now, if we look at the diagrams, we can notice the parts of the pressurized water reactor. Here it is known as control rods, pressurizer, steam generator. This is steam. Here the water is taken. These are the fuel elements. This is steel pressure vessel. Now this is reentry, concentrate containment and shield. Now, if you look at the boiling water reactor, this is the steam pressure vessel. This is steam. These are the fuel elements. This is known as the control rods. This is known as pump, and from here the water is taken. Now, if we see the pressurized heavy water, this is called steam generator. This is called steam. This is called control rods. This is called caldera. No, this is called heavy water. These are the fuel elements, and these are known as the pressurized tubes. Now we are going to discuss about the working of nuclear reactor. 235U fissions by absorbing a neutron and producing 2 to 3 neutrons, which initiate on average one more fission to make a controlled chain reaction. Normal water is used as a moderator to slow the neutrons, since slow neutrons take longer to pass by a U nucleus and have more time to be absorbed. The protons in the hydrogen in the water have the same mass as the neutron and stop them by a billiard ball effect. The extra neutrons are taken up by a protons to form deuterons. 235U is enriched from its 0.7% in nature to about 3% to produce the reaction, and is contained in rods in the water. Boron control rods are inserted to absorb neutrons when it is time to shut down the reactor. The hot water is boiled or sent through a heat exchanger to produce steam. The steam then powers turbines. This is the working of nuclear reactor. Now, due to the nuclear reactor, there is an environment impact. So, what are the impacts? Now we are going to see. The first impact is known as low emissions. Low emissions includes nuclear power has minimal green gas house emissions. Now the second point is known as waste management. Proper disposal of radioactive waste is crucial to prevent contaminations. Now, water impact. Large water usage for cooling can affect aquatic ecosystems. Now, the next point is known as land use. Requires relatively small land areas but can impact surrounding ecosystem. Now, safety concerns. Rare accidents like Chernobyl and Fukushima highlighting risk. Now, these 5 points are known as the environment impact: low waste, low emissions, waste management, water impact, land use, and safety concerns. Now, these are the rules, safety, and regulations. The first one is safety system are in place so that in case of an accident they can protect the contaminant from internal pressure due to steam releases inside the reactor building. In a single unit station, internal pressure would be lowered by spraying water from a dowsing tank. The mechanical properties of the nucleus can directly or indirectly modulate mechanism and the physical coupling of the cell nucleus with the skeleton can affect protein structure and regulate the epigenetic stage, gene expression, and cell function. Now we are going to discuss about pros and cons of nuclear power plant. See, at first, low greenhouse gas emission, high energy density, base load power, and energy security. These are the props. Radioactive waste, safety concerns, high initial cost, prof- professional risk. This is known as the cons. Now, if we see at the first statement, greenhouse gas. Nuclear reactors produce minimal greenhouse gases during operation, making them attractive for addressing climate change concerns. Now, if we come to the second point, nuclear fuel contains a tremendous amount of energy in a small volume, providing a reliable and consistent power source. Now, if we come to the third point, base load power. It is known as nuclear power plants can operate continuously, providing a steady source of electricity, which is essential for maintaining the stability of the power grid. Now, nuclear power reduces dependency on fossil fuel imports, enhancing energy security for countries and limited domestic energy resources. Now, the following are props. Now, coming to the cons, radioactive waste. Nuclear reactors produce radioactive waste that remains hazardous for thousands of years, requiring careful management and disposal. Now, accidents like Chernobyl and Fukushima have highlighted the catastrophic consequences of nuclear accidents, raising public safety concerns. Now, coming to the third point, building nuclear reactors requires significant upfront investment, and the construction process is often lengthy and subject to delays, increasing costs further. Now, if you come to the fourth point, proliferation risks. The material and technology used in nuclear reactors can be diverted for the production of nuclear weapons, posing a proliferation risk. Now, these are the pros and cons related to nuclear power plant. Now, the evolution of nuclear power plant. Evolution of nuclear power plant refers to the advancements and changes in technology regarding design, safety measures, and operational practices of nuclear generation over time. Developments. Generation. These are the following in generation 1 early prototype reactors, shipping port, Magnus in second generation, commercial power reactors in third generation, advanced LWRS in generation 3 plus means coming generations, evolutionary designs offering improved economics for near time development, highly economical, enhanced safety, minimal waste, proliferation resist. Now, advanced reactor designs, digitalization and automatization, small modular reactors, focus on sustainability. Overall, the evolution of nuclear power plants have been marked by continuous improvements in safety, efficient, and in sustainability driven by technological advancements and lessons learned from operational experiences. Now, these are the resources and these are the references from where I have made this PPT. The scientific journals and research papers on nuclear energy and environmental studies, reports and publications from reputable organizations such as International Atomic and many more. You can simply refer. Now, in conclusion, I would like to say that nuclear power presents a complex mix of benefits and risks for the environment. While it offers low greenhouse gas emissions and high energy density, proper management is essential to address significant challenges. These include safe disposal of radioreactive waste, minimizing water usage impact, mitigating land use effects, ensuring safety against accidents, and addressing concerns about uranium mining and proliferation. A, a through life cycle analysis is crucial for emphasizing the need for comprehensive planning and regulation to ensure its role in a sustainable future. Now, I would like to thank you all for attending my seminar and thank you.